I hope you are comfortable with solving equations where they're set equal to 0 now, but this equation has a trinomial in factored form already for us, which is nice, but it's set equal to 4, not 0. So how do we solve this? Well, instead of using the 0 property, we're going to use a property called the square root property. And in another video I go into detail of why this square root property works, but for now we're just going to use it and skip the steps that show all the details of how it works. So I've got my left side already written as a perfect square, and the square root property says that if I have something written as a perfect square, anything over here, x squared, if I have something written as x squared and it equals a number that's greater than 0, then I can go to the next step of x equals plus or minus the square root of that number. So basically I can isolate x and find out what x can be to make that statement true. So using our problem over here, we've got 3h minus 2 squared. So we've got a something squared equal to a number greater than 0. We've got 4. And so I can use the square root property and jump to just writing the inside, 3h minus 2, and set that equal to plus or minus the square root of our number, which is 4. And then from here, I need to get h by itself. Well, I know to move a negative 2 to the other side, I need to do the opposite. So I need to add 2 to it. So what I do to one side, I need to do to the other. So I'm going to do plus 2 over here. And then because we've got a plus or minus, it's really helpful to write the 2 that we just added first before we write that plus or minus the square root of 4. And in fact, I'm going to write plus or minus the square root, or plus or minus 2, because the square root of 4 is 2. The principal root of 4 is 2. And then on the left, we've got 3h left, because negative 2 plus 2 turned to a 0. And then it looks a little complicated, but it's not too bad. We'll break it up into the two pieces in a minute. How do I get rid of the 3? Divide by 3, and then do it on this side. So now I've got h isolated. We have h equals, and we have two equations really. We've got h equals 2 plus 2, and so I'm going to write h equals 2 plus 2 divided by 3. And we also have h equals 2 minus 2 divided by 3. And now that we've split up that plus and minus, it's not too bad to look at. 2 plus 2 is 4, and then 4 divided by 3, I'm going to leave it as a fraction. So h equals 4/3. And then for the second one, we have 2 take away 2 is 0. 0 divided by anything, any real number here, 3, that would be 0. So those are our two solutions. If we plug back either of those into our equation, we can check to make sure we didn't mess anything up. So let's pick 0 first, since that's probably going to be a little bit easier. So right up at the very top, we've got 3 times h. So wherever I see h, I'm going to plug in a 0, minus 2 squared. Does that equal 4? That's what we need to check. Well, 3 times 0 is going to be 0. So then we're going to have negative 2 squared. But a negative times a negative is going to be positive. And so we do end up with 4. So check on that one. Then our other one is 3 times 4/3 minus 2 and then squared. Does that equal 4? Well, I can write 3 as a fraction just like 4/3 is. Any whole number is the same as itself over 1. So now I've got numerator times numerator would give me 12 for the numerator, and then 3 for the denominator. Well, 12 divided by 3, that's 4. So we really have 4 subtract 2, and then we're squaring that. Well, 4 subtract 2 is 2, and then 2 squared does equal 4. So 100% sure that I found the 2 solutions to this equation.